So the second exam should have looked something like this. Your version may be a little bit different. I'm just going to walk through this video. Probably be pretty short because most of the questions are not quantitative, but just either you know it or you don't. So I'll make an announcement in class also that I posted this video, so people don't typically watch this one live, but you can watch it before you prepare for the next exam or the final, or go back and go over your answers to see what you miss. I'll definitely encourage that in class. Okay. So the first one, which one of the following chemical symbols corresponds to niobium? So this is, and hopefully you can read this on the screen. It's not too small. Let me know if it is later, and I'll try to do better next time. But which of the following chemical symbols corresponds to niobium? This one, either you knew it or you didn't. And B is the correct answer. N is for nitrogen, and I is for nickel. As far as the ionic charge for cobalt ion in CO3 and 2, right? We went over how to do this. Several examples in class. Cobalt's one of those transition metals, so the charge it takes is really dictated by the charge of the other atom in the compound. Okay, so the way we approached this was identify that charge on the other atom in the compound. Here it's nitrogen, and nitrogen is one of these, if you look in the periodic table, in a certain row that always adopts a -3 charge. Okay, which means overall, right, this is sort of how we did it in class, setting up this sort of matrix here. -3 charge, there's 2 of them, so that's -6 total. And so that must be perfectly counteracted by the +6 from cobalt. Okay, so we multiplied going down this direction, and going up over here we're going to divide, so 6 here divided by 3 gives us +2. Okay, so the charge on each cobalt is +2. Right, if you were asked to name this, you would have to specify that 2 as a Roman numeral, right? This is the cobalt Roman numeral 2 ion, or cobalt 2 nitride. Number 3, which of the following is a general characteristic of a metal, right? You're familiar with metals, they're shiny, they're typically hard, but they also are a solid usually, and they conduct heat, and they're pretty malleable, meaning I can, change their shape, hammer them into various shapes, and they usually have a pretty high density. So all of the above would be the answer here. Number 4, the compound H2O is classified as which of the following? H and O are both nonmetals, gases, right? So typically when nonmetals are getting together, we call that a molecular compound. There's only one choice here. That's a molecular compound. That's C. Okay. You can also rule out ternary here because that would require 3 or more atoms. There's only 2 types of atoms here, hydrogen and oxygen. Remember, for classifying, it's the number of different kinds of atoms, not the number of total atoms. Okay, so there's H and O, only 2 different kinds of atoms, so it must be binary. Okay, it's molecular because both of those atom types or elements are nonmetals. How many neutrons are in an atom of this symbol right here, 6027CO? Okay, so cobalt again here making an appearance. This top number is neutrons plus protons. The bottom number is just protons. Okay, so we talked about to figure out the difference, or to figure out the neutrons, you take the difference of these two. Okay, difference of those two numbers gives you the number of neutrons. That's 33. Okay, if I had asked for the number of protons, it would just be that bottom number, 27. Okay, or number of electrons, assuming it's neutral, is also that bottom number. Okay, number 6, what model established the concept of a dense central nucleus? Okay, this you just had to review all the various models, and this was really Rutherford, right, with that gold foil experiment, firing the alpha particles, some of them bent or bounced straight back, right? These higher energy bullets hit something and rebounded. That something they hit was this dense nucleus. Okay, so that was Rutherford in his gold foil experiment. Okay, number 7 is a throwback to exam 1. Remember I said, chemistry's cumulative. You're bound to see one, maybe two questions from previous chapter material. And here it is showing up. If a glass marble weighs 3,150 milligrams, okay, what is the mass in centigrams? Okay, so there's my 3,150 milligrams. What am I after over here? Centigrams. Okay, so I know I must be going from milligrams to centigrams. And so I set up my unit conversion, my dimensional analysis the way I always do. Okay, given milligrams, I'm going to need that to cancel. But I don't know directly milligrams to centigrams, so I have to go through that base unit grams first. Again, hopefully you got a lot of experience with this on the first exam, so I'm not going to spend too much time on it here. But you orient the units all this way so that you're left with centigrams at the end. Right, and now it's about remembering there's 1,000 milligrams in a gram and 100 centigrams in a gram. Multiply across the top, divide by the bottom, okay, and that's what gives us 315. So B should be the answer here. Okay, there's a couple of you in the chat. If you do have questions or specific problems you want to go back over or other concepts you want to discuss, go ahead and type them in the chat window. Otherwise, I'm going to go through this video as is. All right, number 8, what is the electron dot formula for boron? Right, the concept here, electron dot formula is expressing the valence electrons for this element. Okay, the element's boron, symbol B. We look at the periodic table, right? It's in that first column or family of the P block, right? It has 3 valence electrons, 2 from the S in that S block, and then 1 P. So there's 3 dots total, right? You start on one side and start adding them, and I should get 3 dots around it. So B is the answer here. B for boron in this case. Number 9, what is the formula unit for the compound composed of calcium and phosphate ions? Okay, phosphate, you know, it's not just P minus, but it's this polyatomic. You could look at the multiple choice and see they're all this polyatomic. So, you know, that should be somewhat obvious, but you go to the table of polyatomics and we see that that phosphate ion has a certain charge. The charge on PO4 is 3 minus. Okay, so I just write that above it. Calcium, where does it live in the periodic table? In the second column, right? That second family or group. And those always, as ions, adopt this 2+ charge. Okay, and then we cross these numbers over and they become the subscripts. Okay, which is why we have calcium 3, phosphate 2. Okay, what is the formula unit predicted? Number 10, formula unit predicted when silver and oxygen combine. Right, this was straight out of a video I posted in the exam review session. So if you watch that, you got this question right. We went over it there. Okay, silver is something that always adopts a +1 charge. Oxygen is something that always adopts 2 minus. Cross it over, that explains Ag2O. Number 11, what's the maximum number of electrons in a 4D sublevel? Okay, I stressed this in class and the videos, knowing the difference between orbital, sublevel, etc. D sublevels have 5 orbitals. There they are, each of which can hold 2. Okay, so every D sublevel can hold 10 total. 2 electrons per orbital, and there's 5 D orbitals in a D sublevel. That's where the numbers come from. 10's the answer. 12, what is the predicted ionic charge for a potassium ion? It's in that first row. It's that S block. Okay, those always want to become 1+. Right? Calcium was in the second row. That's why it wanted to adopt 2+ up here in number 9. Number 13, which of the following elements has the largest atomic radius? Okay, this is about remembering the trends here. Up and to the right is getting smaller. So if I want the largest one, I want the one that is the most to the left and furthest down. If I want the largest one, right? Up and to the right is small, so down and to the left is large. and sodium is the furthest to the left and, you know, the lowest, at least comparing it to these other possibilities. Okay, number 14, which of the following is an alkali metal? This was just, you know, rote memorization. Do you know what the alkali metal group is? It's that first row of the periodic table. The second is alkali earth. Maybe that confused you, but here it should be the first row. Those are the alkali metals. Okay, the only one that qualifies here is cesium. Right, it's in the 6th period of that alkali metal group. Number 15, what is the stock system name for CuOH2? Okay, stock is just sort of like the given system name. We talked about how we name these types of ions. Copper is a transition metal. It's not one of the 3 special ones, so we should definitely expect a Roman numeral. Okay, so B and C can be ruled right out. Okay, either A, D, or E, none of the above. I see these hydroxide terms, and that's exactly what OH is. I have to look that up in my table of polyatomics, and that exists as OH1 minus. Okay, there's 2 of them. So again, taking this sort of matrix approach, that's a total of 2 minus, multiplying down the 1 minus times 2. That means the copper should have a 2 plus charge. And since there's only 1 of them, dividing 2 plus by the 1 copper means it's still 2 plus on that copper atom. Okay, that's why it's copper, Roman numeral 2, hydroxide. Number 16, copper naturally occurs as copper 63 and copper 65. Which isotope is more abundant? Hint, refer to the periodic table. So we go to the periodic table, and we see that the atomic mass of copper is 63.55. Okay, so it's basically deciding, you know, which number is 63.55 closer to. Is it closer to 63 or is it closer to 65? Right, it's closer to 63, so that's the isotope that dominates here. 17, what is the systematic name for S2 minus? Okay, for these anions, we always end them in the IDE suffix, so sulfur becomes sulfide. Number 18, air contains nitrogen, oxygen, argon, and other gases. Which of the following describes air? Okay, it's a mixture. Okay, so we know it's going to be one of these two, C or D. It's not just an element. Okay, it's not just one compound, it's multiple compounds. Okay, it's a mixture of some type, but it's uniform throughout, right? We did this in class as an in-class problem. The breath I take at the front of the classroom is, you know, the same composition as the person in the back, the breath they're taking, right? So uniform throughout means it's homogeneous. Right? And thank goodness, otherwise Dr. Melko, you know, wouldn't breathe at the front of the room the same way you're able to breathe at the back of the room. 19, what's the chemical formula for chlorous acid? Okay, so this one was a tougher one because it relied on us remembering the rules for acids, looking up the polyatomic and changing ATE to OUS and changing ATE to IC and changing ITE to OUS. Okay, so going back and look at the slides, you'll see we went over that naming convention for the acids. Okay, so we go to the polyatomics, and since it's OUS, we have to look, you know, in accordance, is that chloric or chlorate, and we have to select the right one. It's HClO2 here. Number 20, which of the following is an example of a chemical property? Right, we talked about this in class. Chemical, you know, signifies a reaction or, you know, flammability. Those were sort of the 2 keywords here that makes it a chemical reaction or chemical property. Okay, these other things are physical properties. How does it conduct? How dense it is? How much I can change its shape into a wire? That's ductility. Okay, so this should have been a gimme because the flammability keyword that we had talked about is very much a chemical property. 21, a lot of people got this one wrong or were confused by it. Element Z has 2 isotopes. Calculate the atomic mass of element Z given the abundance of one of the isotopes is 49.31. Okay. Inherently, there's only 2 isotopes, so those 2 isotopes must add up to 100%. Okay, so if there's 49.31% of one of them, there's 100 minus that 49.31, or 50.69%. Of the other one. Okay, so 49.31 is Z81, which means this Z79 is 50.69%. Okay, so calculating these isotopes, we did ones like this in class as well. We multiply these isotopes by their atomic mass divided by 100. That's the route. So we take these numbers, 78.918, multiply it by the corresponding percentage here. For 79, it was 50.69. Divided by 100. Then to that we add this 80.916 times 49.31 divided by 100. Okay, adding those two results together should have given this 79.90. 22, what is the electron configuration for an atom of nickel? Okay, this is where you had to, recall on your sublevel ordering and then fill it up with the appropriate 28 electrons for nickel, and the correct order is this first one. Right? You should have 4s2 and then 3d8. Okay. This nickel lives in the D block, so the last one out here had to be D. Okay, so you could have ruled out C right away because it ends in a P8, but nickel doesn't live in that P block. It lives in the D block, so it must end in that particular configuration. 23, which of the following chemical symbols corresponds to zinc? Another one that we just had to recall. Okay, Zr is zirconium, Sn is tin. The only one that's correct, there's only one symbol for zinc, it's Zn. Okay, so that should be A. 24, what is the systematic name for I409? Right, and so this relied on our ability to recall those prefixes, I think they're Greek, for numbering, right? Like 1 is mono, 2 is di, 3 is tri, 4 is tetra. Okay, so 4 iodines would be tetraiodine. Prefix for oxygen is nona, because there's 9 of them, right? The prefix according to 9 is nona, so 4 iodines, 9 oxygens is C, tetraiodine nonoxide. Okay, so that should go through this exam. Again, this is version C. Yours should look similar if you have the other versions. If you have questions about it, come to office hours, let me know, or I'll stick around for a few minutes here and answer any questions in the chat window.